So here's another problem. And this time we're going to graph this quadratic. Okay, so how do I do that? Well, I'm going to go to my calculator, which has turned itself off. I'm going to click the on button. Then I'm going to go to y equals and clear the equation that I currently have there. Then I'm going to type negative xt theta n. I'm going to square it plus 4 xt theta n plus 5. Now I'm done putting the equation into y equals, and then I'm going to click graph and see a good example of what the parabola should look like. Then I'm going to click second and graph again and get a table. Now remember, I want to see from 3 to -3. So let's go, we're going to go up a little bit, and there's 3 to -3. So here, when x is equal to 3, I have an 8. When x is equal to 2, I have a 9. When x is equal to 1, I have an 8. When x is equal to 0, I have a 5. When x is equal to -1, I have a 0. When x is equal to -2, I have a -7. And when x is equal to -3, I have a -16. Now what I want to show you here is that if I had put a 4 up at the top, pretending that our table continued, what do you think the number would be here? If you look at the pattern, it would probably be a 5. And if I go down and look at +4, you can see that my y would equal 5. Remember, the pattern always holds, okay? All right. Now, the reason I included this problem with this table is that I want to show you some problem-solving strategies for finding the roots, okay? We can use the calculator, which I'll show you in a minute, but we can also use our brains. We're very smart. So, let's graph this parabola. 4, 5. So I'm going to go over 4 and up 5. Now, 3, 8. I'm going to go over 3 and up 8. 2, 9. I'm going to go over 2 and up 9. 1, 8. I'm going to go over 1 and up 8. 0, 5. I'm going to stay at the origin and go up 5. -1, 0. I'm going to go to the left 1 and put a dot there. As you can see, that is a root. -2, -7. I'm going to go left 2 and down 7. And then this one is far too big for us to graph, so I'm just going to skip it. But wait a minute. It looks like I only have one root right here. There's got to be 2 roots, right? Where's the second root? Well, there's 2 ways to do this. We can look at the pattern and see that if I added a 5 up here, that the y value would continue the pattern and I would have a 0. Just to point out what I mean, see, here's the pattern, 5, 8, 9, 8, 5. But what comes after the 5? A 0. So what should come before the 5 up here to keep the pattern in line? A 0. So that's how I can use my pattern recognition skills to see outside of just this table of values. So 5, 0 should be the root. But I can also use my calculator. Remember, whenever the y equals 0, that means that the x term paired with it is the root. So here you can see that when y equals 0, I have a -1. So a -1 is a root. And you can see that right here. There's my -1. But let's go down. There's another 0. Do you see that 0 right there? So when y equals 0, x can equal 5, which is what I wrote over here. So I'm going to graph that point. 5, 0 means I'm going to go to the right 5 and put a point there. Okay, now all I have to do is graph my line as best I can. So I'm going to draw the line through the points, trying to be as careful as possible. And there's my parabola. Okay, and if I hit the graph button, you can see that they look very similar. Okay, so questions. What are the zeros or the roots of this quadratic? Well, remember, I said that we already have a root right here, and you can see we have a root here. And also remember that I know my roots by when y equals 0. And you can see that y equals 0 here, and y equals 0 here. So that means that 5 is a root, and -1 is a root. You can also see it on the graph. So when x, let me scroll down a little bit, when x equals 5 and when x equals -1, those are my two roots. Whoops. So these are the roots of my equation. Does this quadratic have a maximum or a minimum? Well, it should be pretty easy to see. We have a high point right here on our parabola, which means that that is a max. So this is my maximum. It's at the top of the hill, and that is at y equals 9. So I have a maximum at y equals 9. Okay, last question. What is the axis of symmetry? Remember, x equals -b over 2a. And my equation is -x squared plus 4x plus 5. So -x squared plus 4x plus 5. Whoops. 5. So this would be my A, this would be my B, this would be my C. So I have an invisible 1 right there, which means that -1 is my A, 4 is my B, and +5 is my C. So let's write those down. A is -1, B is 4, and C is 5. Now all I have to do is take these numbers and sub them in. So, -4, oh, forgot my x equals, -4 over 2 times -1. That tells me that x equals -4 over 2 times -1 is -2. So x equals a negative over a negative is a positive, and 4 divided by 2 is 2. That's my axis of symmetry. And just to show you on the graph what that looks like, where does x equal 2? Right there. So my line of symmetry, my axis of symmetry, is going to go through that point where x is equal to 2. And as you can see, when x is equal to 2, the line goes through the maximum and through the point where x equals 2 all the way to the bottom. Okay, guys, so those were 2 more examples of how to use your graphing calculator to make your life easier. As always, be sure to check the Google Classroom for a bell ringer and a homework assignment. And as usual, please stay safe.